Good evening, learners. I hope you are doing well. Today we are going to proceed with the topic that we started yesterday, that is gradient and equation of straight lines. And yesterday we introduced ourselves to finding the gradient or the slope of a line. We proceeded to determining the equation of a line. Now in this lesson, we are going to learn about parallel and perpendicular lines. And before we start this lesson, I've noted that a majority of my learners have not subscribed to my YouTube channel. So ensure that you subscribe, ensure you share and you like this video so that each and every time I upload a new video, you will be updated. So we are going to start our lesson today from parallel lines. And from parallel lines, we can simply start by defining what parallel lines are, and we can say that parallel lines are straight lines. They are straight lines. Parallel lines are straight lines whose distance between them is the same. So the distance between the two lines from any given point is the same. So if you observe clearly, if we say this is line AB and this is line PQ, we can say that AB is parallel to PQ. AB is parallel to PQ. So why is it important for us to understand the concept of parallel lines in gradient and equation of straight lines? The reason the concept of parallelism is important is because parallel lines have the same gradient. 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 By saying parallel lines have the same gradient, we mean that given the lines y is equal to 2x minus 1 and y is equals to 2x plus 5, we can conclude that these two lines here are parallel to each other. The two lines, for instance, if we say this is line 1 and this is line 2, we can say that line 1 is parallel to line 2 because their gradient is 2. Because their gradient is 2. Why are we saying that their gradient is 2? We are saying their gradient is 2 because remember the general equation of a straight line is equal to y is equals to mx plus c, where m is the gradient. So in this case, our m here is 2 and our m here is 2 because y is equals to 2x minus 1 and y is equals to 2x plus 5 conforms the general formula y is equal to mx plus c. So the key point to note here is that parallel lines have the same gradient. This is the key point to note. Parallel lines have the same gradient. Parallel lines have the same gradient. So we will now proceed to doing some examples. Proceed to do some examples. So our example 1 is that line L1 whose equation is y is equal to 4x minus 4 is parallel to line L2 whose equation is parallel to line 2 that passes through or which passes through 2 1 Our question is find the equation of line 2. Find the equation of line L2. Find the equation of line L2, 3 marks. So we've been told line L1 whose equation is y is equal to 4x minus 4 is parallel to line 2 which passes through 2 1. Find the equation of line 2. So in this question we have already been told that line 1 is parallel to line 2. These two slashes simply means the two lines are parallel to each other. And as we have said, in such a scenario, the gradient of the two lines is the same. So when two lines are parallel, their slope is equal. And in this case, for line 1, the equation is y is equal to 4x minus 4. So if the equation is y equals to 4x minus 4, bearing in mind the general equation of a line is y is equals to mx plus c, our m there as our gradient is equal to 4. And having our gradient equal to 4, it means that even the gradient of line 2, our m is still equal to 4. Our m is equal to 4. Why is our m equal to 4? Because in parallel lines, the gradient is the same. And we have been told it is parallel to line 2 which passes through 2 1. So line 2 passes through 2 1. So another thing to consider is that line 2 passes through coordinate 2 1, and this coordinate 2 1 being a point where the line cuts across or cuts along, the gradient of the line is 4 and the arbitrary points of the line are x and y. So for us to determine the equation of the line 2, we will now proceed with what we did in our last lesson. So if you are now following this is lesson number 3. In our lesson number 2, we had already covered how to determine the equation of straight lines given two coordinates. So in this case, we will now use the concept we used in lesson 2 to answer this particular part. And we will now take the change in y, which is y minus 1, over the change in x, which is y x minus 2, is equal to 4 over 1. And by doing so, we will get 1 into brackets y minus 1 is equal to 4 into bracket x minus 2. So when we get that, we will now take 1 multiplied by y is y, minus 1 times 1 is equal to 4 times x is equal to 4x, minus 4 times 2 is equal to 8. So when we get that, we now need to write our answer in form of y is equal to mx plus c. So we will take this to the other side of the equal sign, and we will end up having, let's lab and use this part here. So we will have y is equal to 4x minus 8 plus 1. Why plus 1? Because when we take negative 1 to the other side of the equal sign, it is going to be plus 1. So by doing so, we will now have y is equal to 4x minus 8 plus 1 is equal to minus 7. So that will be the equation of line 2. That will be the equation of line 2. We can do some more examples. Example 2. So example 2 says, a straight line passes through points A, negative 3, 8, and B, 3, negative 4. Find the equation. Find the equation of the straight line through 3, 4 and parallel to AB and parallel to AB and parallel to AB. Give your answer. In form of y is equal to mx plus c. That is equal to 3 marks. That is equal to 3 marks. So a straight line passes through points A, negative 3, 8, and B, 3, negative 4. Find the equation of the straight line through 3, 4 and parallel to AB. So we are supposed to determine the equation of a straight line which is parallel to AB. So that simply means on our solution part, we are finding the equation of line AB which is parallel. It's an equation of a line. We don't know that line, we can just call it L. But the line is parallel to AB. And in this case, we have been given the coordinates of A as negative 3, 8, and the coordinates of B as 3, negative 4. So for us to answer this question, we will first determine the gradient of line AB. And how we determine the gradient, we discussed it in our video number 1 and said for us to determine the gradient, I hope in this case if I use M to represent the gradient of AB, you will understand because M is a representation of the gradient from our equation. So we have our M, which of AB as change in Y over change in X. That is what we said, change in Y over change in X. So in this case, we have our Y as negative 4, Y2, our Y1 is minus 8 over our X2 is 3 minus our X1 is minus 3. and we will get our m of AB, which is the gradient of AB, is negative 4 minus 8 is equal to negative 12 over 3 minus 3 is equal to positive 6. Why positive 6? Because a negative and a negative ends up being a positive. So we will end up having negative 12 divided by 6, which is equal to negative 2. So having the gradient of our line AB as negative 2, we can conclude that the gradient of line L, which is the unknown, the line to which we are supposed to determine our equation, is also equal to negative 2. Why negative 2? Because we said for parallel lines, the gradient is the same. So having negative 2 as our gradient, and we have been given the coordinate, find the equation of the straight line through 3, 4. 3, 4 is the coordinate to which line L is passing through, passing either across or along. So our line L is cutting across 3, 4. So we will now take 3, 4 as our point of contact between the line. Then we have our gradient, which is negative 2 over 1, and we have our arbitrary points, which are x and y. So having that, we can now proceed to finding the equation of the line. And for us to find the equation of the line, we will take y minus 4 over x minus 3 is equal to negative 2 over 1. Y minus 4, that is change in y over change in x minus 3 is equal to negative 2 over 1. Then we cross multiply, and when we cross multiply, we will have 1 multiplied by y minus 4 is equal to negative 2 into bracket x minus 3. So once we get that, we can now proceed to open our brackets. 1 times y is equal to y. 1 times negative 4 is equal to minus 4 is equal to negative 2 times x is equal to negative 2x. Negative 2 times negative 3 is equal to plus 6. Is equal to plus 6. So having that, we can now put our like terms together. We will take negative 4 on to the other side of the equal sign, and we will end up having y is equals to negative 2x plus 6 plus 4. And that will definitely give us y is equals to negative 2x plus 10. And that will be the equation of the line parallel to AB. That will be the answer to the equation of the line parallel to AB. So having that as our second example, we can still do another question. We can still do another question on parallel lines, so that we can now embark on perpendicular lines. Perpendicular lines. Perpendicular lines. So that is how we go through parallel lines. So we have another question here. Example 3. The equation of line L1 is 2y plus 3x is equal to 5. Find the equation of line L2 which is parallel to line L1, and passes through -1, -4, and passes through -1, -4. 3 marks, and passes through -1, -4. So let us answer this question. Let's answer this question. So we have been told the equation of line 1 is 2i plus 3x is equal to 5. So we are now on solution. 2y plus 3x is equal to 5. So given the equation of line 1 as 2y plus 3x is equal to 5, we need to write our equation in form of y is equal to mx plus c. We have to write our equation in form of y is equal to mx plus c. This simply means that we need to write our equation in this format. So we need to start with y, that is 2y. Then we put an equal sign. So this simply means we need to take plus 3x on the other side to have negative 3x. Then the constant will still remain plus 5. The constant will still remain plus 5. Then for us to determine the gradient m, we need to ensure that the coefficient of y is 1. So we will divide everything with 2, with 2, with 2, and we'll end up having y is equals to negative 3 over 2x plus 5 over 2. So this equation is the same with this one. These two equations are the same. They are the same. It is just that this equation is written in form of y equals to mx plus c. But this one was not written in form of y equals to mx plus c. So what we are now going to do is that we will now identify the gradient of our L1 as negative 3 over 2. And definitely the gradient of our L2 should also be negative 3 over 2. So when we have the gradient as the same, we will now proceed to determining the equation of line 2. Bearing in mind, we have the point of contact, which is negative 1, negative 4. Then we have negative 3 over 2, and we have our arbitrary points as x and y. And by having that, we will now proceed to determining the equation of the line. And how are we going to determine the equation of the line? We will say y minus minus 4. So it will be y minus minus 4 over x minus minus 1 is equals to negative 3 over 2. Is equal to negative 3 over 2. So let's wrap this area. So y minus minus 4, y minus minus 4, that simply means y plus 4 over x minus minus 1, it simply means x plus 1, is equal to negative 3 over 2. Negative 3 over 2. So this means we now have to cross multiply and have 2 into brackets y plus 4 is equals to negative 3 into bracket x plus 1. Negative 3 into bracket x plus 1. And this will give us 2 times y is equal to 2y. 2 times 4 is equal to 8. Equals negative 3 times x is negative 3x. And negative 3 times 1 is equals to negative 3. So that will give us 2y is equals to negative 3x. We now take this to the equal sign. Minus 3 minus 8. Why minus 8? Because from the on the left hand side it is a positive, so when we take it to the right hand side it automatically becomes a negative. So we will now have 2y is equals to negative 3x minus 11. Minus 11. And by having that, we can divide both sides by 2, by 2, by 2. And we'll end up having our equation as y is equals to negative 3 over 2x minus 11 over 2. That will be the equation of line 2, which is parallel to line 1. I think with those examples that we have done, they are enough based on parallel lines. We can now embark on perpendicular lines. We can embark on perpendicular lines. Let's now embark on perpendicular lines. Perpendicular lines. So, what we really need to understand about perpendicular lines is that these are straight lines. Perpendicular lines are straight lines that intersect at right angle. That intersect at right angle. They intersect at right angle. Perpendicular lines are straight lines that intersect at right angle. For instance, if we have two straight lines, we have line 1, or allow me, instead of saying line 1, let me use an example of a Cartesian plane. We are all familiar with a Cartesian plane. We have the x-axis and the y-axis, and this here at 0, or what we call the origin, is always a 90 degree. It makes a 90 degree angle. So in this scenario, we can say that the x-axis is perpendicular. We can demonstrate by that, using that. It is perpendicular to y-axis. X-axis is perpendicular to y-axis. Why? Because the two lines are intersecting at a right angle. If you check clearly, this is 90 degrees. So that simply means that the two lines are intersecting at a right angle. So what do we need to understand about perpendicular lines? So the key point about perpendicular lines is that the product of their gradient, the product of their gradient, the product, underline the word product, the product of their gradient is equal to -1, is equal to -1, is equal to -1. The product of their gradient is equal to -1. It is equal to -1. So what that means is that if we have two lines, if line 1 whose gradient is m1 and line 2 whose gradient is m2. Why are we saying m2? Is because their gradient is not the same. So we can end up concluding that the gradient of line 1 multiplied by the gradient of line 2 is equal to -1. The gradient of line 1 multiplied by the gradient of line 2 is equal or is equivalent to -1. So having that in mind, we can now be able to answer questions related to perpendicular lines. But before we respond to some questions related to perpendicular lines, I want us to analyze or perhaps have some few examples here where we can try to determine the gradient of the perpendicular line. So, for instance, given the following lines, comma, find the gradient of their respective perpendicular lines. Find the gradient of their respective perpendicular lines. Find the gradient of their respective perpendicular lines. A, we have y equals to 2x plus 3. B, 2x minus 3y is equivalent to 4. Then C, we have 3y plus 2x minus 5 is equal to 0. So we have a set of lines. We have the first line, the second line, and the third line. And in each case, we are supposed to determine the gradient of their respective perpendiculars. The gradient of their respective perpendiculars. So we have our solution here. So to simplify this so that we can understand and be in one accord, what I'm saying is that, for instance, the first one is y is equal to 2x plus 3. Let us agree and call that line 1. We now want to find the gradient of a line perpendicular to this. A line perpendicular to y equals 2x plus 3. So, given this line, we can be able to determine the gradient of the line perpendicular to it. So what we are going to do, we can now call that line we are determining the gradient line 2. And we can say that since the equation of a line is in form of y equals mx plus c, where m is the gradient and here our m is 2, that is in line 1. For us to get m2, this is m1. For us to get m2, which we don't have, which we want to determine, we will say m1 times m2 is equal to -1. m1 times m2 is equal to -1. So our m1 is 2 times, we don't have m2, is what we are determining, is equivalent to -1. Is equivalent to -1. So we will take 2 multiplied by m2 will give us 2m2 is equal to -1. And for us to get m2, we will divide both sides by 2, and we'll end up getting our m2 as -1/2. If you can confirm using your scientific calculator, you can you can agree with me that negative a half multiplied by 2 is equal to negative 1. Negative a half multiplied by 2 is equal to negative a half. So that confirms that the two lines will be perpendicular. Let's proceed to do example B. Let's proceed to do example B. Example B, we have 2x minus 3y is equal to 4. 2x minus 3y is equal to 4. And for us to determine the gradient of that line, we need to first write our equation in form of y equals to mx plus c. So we have y here, which is negative 3y is equal to, we will now take the x to the other side of the equal sign, and since here it is 2x which is positive, once it gets to the other side it becomes negative 2x, then 4 will remain there as plus 4. As plus 4. This has been left on this side because it is on the left hand side, and now we have taken 2x to the other side to have negative 2x, then plus 4. 4 will not be affected. It will still remain on the right hand side of the equation. So what we are now going to do is, for us to be left with y, remember you cannot determine m, the gradient, if the coefficient of y is not 1. You must ensure that the coefficient of y is 1, and your equation is written in form of y equals to mx plus c for you to determine the gradient. So we will now divide everything with negative 3, negative 3, negative 3, and we will end up getting y is equals to, we can now divide negative and negative will become positive. We will have 2 over 3x, positive and negative is negative, minus 4 over 3. So when we have that equation, this equation is the same as this one. There is no difference between this and this. The only difference is that the two equations have been written in different ways. This one is written differently from this one, but this one is equal to this one. So in this format, we can now conclude that our m1 is 2 over 3. We can definitely define our m1 as 2 over 3 just by the look of the eyes. Remember, to determine the gradient when the equation is written in form of y equals mx plus c, you only need to use your eyes. You don't have to think about it. You can just compare the general equation with the real equation, and you can be able to denote the exact figures and obtain the gradient as 2 over 3. So what we are now going to do is, we are now going to use our formula m1 times m2 is equal to negative 1. So in this scenario, we have our m1 as 2 over 3. We can multiply with m2, which is equivalent to negative 1. And by doing so, 2 over 3, let's finish that at this point. Two over 3 multiplied by m2 will give us 2 over 3 m2. Sorry, 2 over 3 m2 is equal to negative 1. So for us to be left with m2, we will multiply both sides by the reciprocal, which is 3 over 2, which is 3 over 2, and we'll end up getting our m2 as negative 3 over 2. We'll get our m2 as negative 3 over 2. We'll get our m2 as negative 3 over 2. So by doing that, we will now proceed to the last question. And our last question is 3y plus 2x minus 5 is equal to 0. So that was our last part of the question, where we are supposed to determine the gradient of the perpendicular. The gradient of the perpendicular. So what we are going to do is that we have to write our equation in form of y equals to mx plus c. So we will hold 3y there, introduce the equal sign as it is. Then we will take plus 2x to the other side of the equal sign to be negative 2x. And after doing so, we will now take negative 5 to the other side to become positive 5. Once we get that, we can now divide both sides by 3, by 3, by 3, so that we are left with our equation with the coefficient of y as 1 and get negative 2 over 3x plus 5 over 3. Negative 2 over 3x plus 5 over 3. So, here you can conclude that m1 is negative 2 over 3. Can you determine m2? And give me the answer on the comment section. Give me the answer on the comment section. I not do that one for you. We've done the first and the second one. I believe having this one and this one, you can now be able to determine m2. Remember, the formula is m1 times m2 is equal to negative 1. So you can be able to determine m2. So by having that, I hope you have copied that question. You can proceed and give me the answer for that one. I want us to now proceed with more questions on perpendicular lines. More questions on perpendicular lines. We have more questions on perpendicular lines. Find the equation of the perpendicular to the line x plus 2y is equal to 4 and passes through point 2,1 and passes through point 2,1 2 marks. Find the equation of the perpendicular to the line. Find the equation of the perpendicular to the line. X plus 2y is equal to 4 and passes through point 2,1 and passes through point 2,1. So in this scenario, we will first write this equation here. X plus 2y is equal to 4. We need to write it in form of y equals to mx plus c. mx plus c. And we will start with 2y as it is and say equals. Since x is on the left hand side, we will take it on the left hand side, on the right hand side to get negative x. Then we will now have plus 4. And so that we can be left with y alone, we will divide by 2, by 2, by 2, and we'll end up having the same equation as y equals to negative x over 2 is the same as negative a half x plus 2. 4 divided by 2 is 2. So, since we have been told to find the equation of the perpendicular line to the equation, we have been told to find the equation of the perpendicular to the line this and passes through point 2,1. So in this case, we can now be able to derive our m and say our m1 is negative a half. this is our M1. Why? Because it conforms the general formula y equals to mx plus c, and therefore we can be able to proceed. So what we are now going to do is that we will now use this gradient. Remember, m1 times m2 is equal to -1. So we will take -1/2 times m2 is equivalent to -1. So -1/2 multiplied by m2, it will be equal to -1/2 m2 is equal to -1. -1/2 m2 is equal to -1. So we now multiply both sides by the reciprocal. 2 over -1 multiplied by 2 over -1, and that will give us m2 is equal to negative, and negative will come to an end. We have our m2 as 2. We have our m2 as 2. So having our m2 as 2, we will now take the coordinates, which is 2, 1. The gradient is 2, and the arbitrary point is x and y. And the arbitrary point is x and y. So we now have y minus 1 over x minus 2 is equal to 2 over 1. And when we cross multiply, 1 times y minus 1 will remain to be y minus 1 is equals to 2 into bracket x minus 2. 2 into bracket x minus 2. So if we open that bracket, we will have y minus 1 is equal to 2x minus 2. 2x minus 2. So if we take -1 to the other side of the equal sign, we will have y is equals to 2x minus 2 plus 1. And that will be y equals to 2x minus 2 plus 1 is minus 1. And that will be the equation of the line. That will be the equation of the line. That will be the equation of our line. So let us do another example. Let's do another example. Example 2. A line L passes through point 31 and is perpendicular to the line 2y is equal to 4x plus 5. Full stop. Determine the equation of line L. Determine the equation of line L. 3 marks. That is another question that we are supposed to answer on perpendicular lines. A line L passes through point 31 and is perpendicular to the line 2y equals to 4x plus 5. Determine the equation of line L. So we've been told that line L is perpendicular to this line. So we first identify the equation of the line given, 2y equals to 4x plus 5. And this equation is already in the form of y is equal to mx plus c. but you must ensure that the coefficient of y is 1. So having 2y is equal to 4x plus 5, we have to divide everything with 2 to get y equals to 4 divided by 2 is 2x plus 5 over 2. 2x plus 5 over 2. So our m1 in this case is 2. If our m1 is 2, can you determine m2? Determine m2. So m1 times m2 is equal to -1. So 2m2, 2m2 is 2 times m2 is equal to -1, and that will give us our m2 as -1/2. So when we get our m2 as -1/2, we will now take the coordinates, which are 3 and 1, and we will now take our gradient -1/2, and their arbitrary points will be equivalent to x and y. So once we have that, we will take y minus 1 over x minus 3 is equal to 1/2, and we cross multiply. Y minus 1 over x minus 3 is equals to -1/2. Then we end up cross multiplying. And after we do that, so we now take 2 multiplied by y minus 1. 2 multiplied by y minus 1 is equals to -1 multiplied by x minus 3. -1 multiplied by x minus 3. And that will give us 2 times y is 2y minus 2 times 1 is 2 is equals to -1 times x is -x. -1 times -3 is +3. When you take a negative number multiplied by a negative number, it is going to give you a positive number. So -1 times -3 is equal to 3. So that will definitely give us 2y is equals to minus x plus 3. Then we take -2 to the other side to be +2. So that will be 2y is equals to minus x plus 5. And we divide both sides by 2, by 2, by 2, and we end up getting our y is equals to -1/2 x plus 5 over 2. -1/2 x plus 5 over 2. -1/2 x plus 5 over 2. So I will leave you with a question. Let this be an assignment you can do during your free time, or you can take it as your assignment. Same questions repeated in your KCSE examinations. So just review with one question to do, which we can just call an assignment. So you have a perpendicular is drawn from a point 3, 5 to the line 2y plus x is equals to 3. Find the equation of the perpendicular. 3 marks. Find the equation of the perpendicular. 3 marks. Number 2, that is number 1. Number 2, a perpendicular to the line y is equals to, y minus 4x plus 3 is equals to 0 passes through the point -8,5, passes through the point -8,5 determine its equation. Determine its equation. 2 marks. So those are my assignment. That is my assignment, the assignment that I've given you. Ensure you answer those questions. And perhaps you're asking yourself, after you answer those questions, where will you submit that work? I'll give you my number. My number is +254 742 0908 25. +254 742 0908 25. That is my WhatsApp number. That is my WhatsApp number. You can submit that work via my WhatsApp, or you can still submit this work or through Top Grade Maths Academy @gmail.com. Top Grade Maths Academy @gmail.com. Top Grade Maths Academy @gmail.com. We've come to the end of our session today, and in our next lesson, we'll be learning about the x and the y-intercept. The x-intercept and the y-intercept. That is in our next lesson. We'll be learning about. So in our next lesson, we'll be learning about the x and the y-intercept. The x and the y-intercept. And we also mentioned something about the points of intersection. Points of intersection. And that will mark the end of the topic, equation of a straight line. That will mark the end of the topic, equation of straight lines. So this is a very, very crucial topic. It is commonly assessed in paper 1. And I've made up my mind that we are going to be doing this until we are done with all the topics as far as paper 1 is concerned. If you have any question, feel free to drop your question on my WhatsApp or my business email. And once you do that, I believe that you will stand a better chance to understand. I remain your favorite teacher, Teacher Asaf, and I'm a mathematics and chemistry teacher. I'm purposed to turning confusion into clarity, helping you in your weak areas, not just locally but internationally. So if you are interested in my private tutorials, if you are interested in my services, you can call me via that number, or you can also WhatsApp me through that number, +254 742 0908 25. You can also email me at topgrademathsacademy.gmail.com, and we are available to provide the best services to you and ensure that confusion meets clarity. Have a blessed night. Have a good night, and may the Almighty God bless you. Thank you.